Managing undo segments. In this nugget, we'll talk about what exactly an undo segment is and why you'd want to use it. Basically, undo segments are going to be used to remember before information, before you modify your data, in case you need to roll back or do other things. So we'll talk more about that in just a moment. We'll also talk about the history of undo. Prior to Oracle 9i, we had this thing called rollback segments, which served almost the same purpose. It didn't have quite the same functionality, but we'll talk about the difference between rollback and undo. And in 10G, undo has a couple enhancements to make it easier to manage. Then we'll talk about what we need to do to configure undo. For example, we'll talk about the different initialization parameters and how to specify what your default undo table space is. We're also going to discuss sizing the undo table space. If you're getting a lot of snapshot too old errors, this is definitely related to the sizing of the undo table space. So I'll show you how to avoid that error. And then the last thing we'll talk about is how to create, alter, drop, and switch your undo table spaces. Now the whole purpose of my undo segments is to remember information about my data before I make the changes to my data. For example, if I give everyone in the employee table a 50% raise, the before salary is going to be stored in the undo segments. Well, why in the world would we even want to remember this information? Well, for one, read consistency. If you take a look at this timeline down here in green, let's assume that I issue a select statement right here at the T1 marker. And let's also assume that this query that I'm issuing is going to take quite a long time, maybe 10, 15 minutes. When I issue my statement, I want to retrieve all the information at the point where I actually issue the statement. In other words, let's say that I issue the statement right here and maybe 2 seconds later some other users are modifying the data. I don't want to get all their modified data here. I want to see all the data at this point. Well, that alone is a good enough reason for undo. Some other reasons. Rolling back transactions. For example, if I made some modifications to my data and then decided, you know what, I don't want to make those changes, I want to undo everything, I can roll back my transaction, which undoes all of the changes that I made since the beginning of my transaction. Now, a rollback or a commit statement marks the beginning of a transaction. Another reason why we might use undo is to recover a database. Let's assume that some kind of corruption went on and we had to go back to our last full backup of the database. So we would take that backup and restore the data file. So that would be step 1 down here. Then the next step would be to recover the database. Recovering just means that you're taking all the redo logs and applying it to the restored data files. But it's important to remember that the redo logs are not really aware of what has been committed or not. Okay, so the third step would be to apply any undo to that data. So think of it as we restore the data files, we do a fast forward and then a little bit of rewind to undo any uncommitted transactions. Now we'll talk more in detail about the recovery and restoration process in another nugget, but this is the big picture here. And one last reason for using undo, and that's for Oracle 10G flashback query. Flashback query is a way that we can query what the state of the database was at a particular point in time. For example, if I want to say select star from person at a particular point in time, let's say 15 minutes ago, I can do that if I have configured my undo table space correctly. Now, undo segments and rollback segments essentially do the same thing. Rollback segments are available in 10G and earlier, whereas undo segments are only available in 9i and later. Now, even though we can have the choice between rollback segments and undo segments, we really try to stick to undo segments. It will make the management much, much easier. Well, the way rollback segments worked was that if you had a table that was, let's say, in your users table space, well, all the undo information or all the rollback information would be stored in the same table space. So you might end up managing multiple rollback segments, which could be really, really cumbersome. Now with undo segments, we just let Oracle manage it all for us, and we just say, hey, here's our undo table space. You manage everything except for the sizing. And Oracle even gives us a nice little tool called the Undo Advisor to give us hints on how to size it. So it's going to save you a lot of time as DBA. Let's talk about what it takes to configure your Oracle 10G database to use automatic undo management. By default, Oracle 10G relies on the DBA to manually manage the undo segments. In other words, if you do not explicitly specify that you're using automatic undo management, it's going to use rollback segments. So in your initialization parameter file, either the init.ora file or your SP file, you need to specify your undo management is equal to auto. If you want it to be the other way around, using rollback segments, then you would set this to be manual. Now you can have more than one undo table space in your database, but only one of them is going to be active at a given time. So if you have more than one undo table space defined in your database, then you need to specify which one is in use. So that's where we specify that right here. Now this third parameter, undo retention, this defines the number of seconds that we want Oracle to hold on to undo information. But to understand this concept, you need to understand what active undo and inactive undo is and how that relates to queries. Let's look at my statements down here. My first statement is select star from emp. That statement might be a really long-running statement if my employee table is a really large table. So let's say that a split second later somebody else issues an update emp statement and updates some of the records that are getting queried from here. What's going to happen is this original select will then have to grab information from the undo table space. You see, when this update employee statement is issued, it's actually taking the before data and stuffing it into the undo table space. So we have read consistency. And we might have some more statements that's modifying our data here. For example, delete from emp. That too will create some undo information. When we say that we have some active undo, it means that that data is still necessary to perform a rollback. If I perform a commit, then it's no longer active. It's actually inactive, but it still might be used. For example, it might be used by this select statement. So if we set our undo retention to be 1800 seconds, which is 30 minutes, we're telling Oracle that we'd like it to hang on to this undo information for at least 30 minutes. Now, Oracle's only going to honor that request if you have enough space in your undo table space. We'll talk about sizing your undo table space here in just a moment. Now let's assume that your undo table space is a fixed size and we've got some active as well as inactive undo segments, and then we might also have some free space in there for more undo information to get put in there. Now, Oracle's going to get rid of inactive undo before it gets rid of any active undo, and it flushes it out on a first in, first out basis. And let's assume that you issue this select star from emp and it's a really long running query. Let's assume, hey, this query might take several hours. Okay, and all of a sudden in the middle of your query running and you get this error that comes back saying you've got a 1555 snapshot to old error. This is a really well-known Oracle error that most DBAs have encountered at some point or another. What that exactly means is that this query wasn't able to complete because there wasn't enough space in this undo table space. So if that happens, most likely what you're going to have to do is resize the undo table space, make it larger. Let me show you how to manually size the undo table space. Let's go ahead and manually size our undo table space. Oracle provides us with a nice little view called $undo stat, which allows us to see in 10-minute intervals how many undo blocks were generated. So when we talk about the transaction rate of your database, what we're talking about is the number of database blocks that were generated per second. So to calculate that, you take the highest number that you get from this view, and then you divide by 600, since there's 600 seconds in 10 minutes. So to calculate how large your undo table space should be, you want to take this transaction rate that you got, multiply that by your block size. You can get that from your initialization parameters, and then you multiply that by your undo retention, the number of seconds that you want Oracle to hold on to your inactive undo. So let's look at my query here. I'm grabbing my begin time, my end time, and the undo blocks. Note that I'm using the toChar function to show not only the month, day, and year, but also the hour and minutes, so we can see the actual times. And then undo blocks right here from $undo stat. So I'll go ahead and execute this. And it's only going to keep 4 days worth of information. Okay, so you see here this entry, we had quite a bit of undo compared to the other entries. Let's just assume that this is the highest number, or if you want, you can do an aggregate function. So I went ahead and found the max of my undo blocks from $undo stat, and there's my number there. And I grab my handy little built-in calculator, select 5361 divided by 600. Remember, there's 600 seconds in 10 minutes. From dual, so we get 8.935 undo blocks generated per second. Now, show parameter undo retention. Looks like it's set to 900. If you wanted to change that to something higher, that's perfectly fine. We'll just leave it like it is. And then show parameter DB block size to show us our database block size, 8K. So let's do the math. And there we go. We've got about 65 megabytes. Now, it doesn't hurt to round this up a little bit. In a real production environment, it can be much, much larger. Oftentimes I've seen in the gigabytes. Now, if you've got your Enterprise Manager configured, which we'll cover in a later nugget, then you can use the Undo Advisor through a graphical interface, and it's much easier to do. It just performs all the calculations for you. So to get there, from the main page, you go to the Undo Management and then click on Undo Advisor. You get to this page. Now, you can specify how long you want to have your undo retention. You can specify in hours, days, or minutes, and you can choose the analysis time period that it's selecting from. Now here you'll see that it says last 7 days. Well, a couple minutes ago, I told you that $undo stat only keeps information for 4 days. However, there is another view called DBA undo extents, which has more historical information that goes back further. And so after you plug in that information, it's going to generate a nice little chart here. The x-axis here is your undo retention, and you'll see as that is increasing, your table space size for your undo table space also increases. So you can just follow the line on this chart, and you can say, well, okay, if my undo retention is set right here, then my table space size needs to be this amount. Well, now I'm going to show you how to create an undo table space. Your database has to have at least one undo table space, and exactly one of them is going to be active at any given point. Now there's 2 ways to create this undo table space. One of them is with our create database statement when you initially create your database. So here's our create database statement. We have lots of clauses that go in there. You should recognize this from a previous nugget. And then we have a clause where we specify the undo table space and the data file that goes with it. You might have more than one data file. So this clause right here, size 5M auto extend on, this pertains to the data file. So the initial size is 5 megabytes. If we specify auto extend on, that just means that if the amount of active segments exceeds 5 megabytes, this file is automatically going to grow for us, so we won't encounter an error. So potentially this data file could get rather large. Now another way to create your undo table space is with the create undo table space statement. Now this is going to be issued, of course, after your database is already set up, and you would do this if you want to switch out an undo table space. So let's assume that you have right now exactly one undo table space and you want to change it to something else. Well, you're going to have to create another table space and then switch it out. So we give it a name, and then we have to specify at least one data file. Here I said size 10 megabytes, so that's the initial size. The reuse clause means that if this file already exists on the OS level, then it's going to reuse it. Now, we have this clause here so we don't encounter an error if it already exists. Now, there is a clause called retention guarantee that is only available in 10G release 2, and this is a really interesting clause here. What this does is that it guarantees the undo retention. For example, if you specified your undo retention to be 900 seconds, then we're basically preventing any of those snapshot too old errors. But the drawback is that this might be at the expense of inserts, updates, and deletes. For example, if your undo table space is already full of active undo segments, and you try to issue a delete statement or an update statement that tries to generate more undo, and there's not enough space in there, it's actually going to fail. That statement's going to fail and your statement's going to roll back. But the advantage of it is that your users issuing the select statements are not going to get that ugly snapshot too old error. So you can specify that retention guarantee in your create database statement as well. There's several ways to alter an undo table space. For example, if you need to add a data file, well, you're going to say alter table space, then the table space name, add data file, the full path to it, specify the size, and you can use all these clauses like reuse or auto extend on. If you want to modify a table space to have the retention guarantee, you'd simply say alter table space name, retention guarantee. If you wanted to turn off the guarantee, then you would say alter table space, retention, no guarantee, and that's one word. Now, if you want to rename one of your data files in your undo table space, keep in mind that that's going to be an alter database statement. Okay, so alter database, rename file, you have the full path to your old file, and then the full path to your new file. And this operation requires that you have your database in the mount mode. So there is some downtime involved with this. Okay, switching the undo table space. Let's assume that you've got two undo table spaces defined in your database and one of them is active. Well, if you want to make the other one active, you're simply going to say alter system, set undo table space equals, and then the new table space name. Now, this is going to be perfectly seamless to the end user. Your users are not going to notice any change in the database. And what happens is, at this point, any new transactions created by a user are going to begin in the new table space. And the old undo table space is now going to be in the pending offline mode, which means it's just waiting for the transactions to finish up. It's waiting for users to issue commits. Okay, so it's going to be in that state until there's no more active undo in that table space. If you need to drop an undo table space, it's real simple. Drop table space name, and this optional clause. Including contents just means dump all the contents, and data files removes the data files on the operating system level. This clause here is a really good idea to do so you don't end up with these rogue data files that are doing absolutely nothing except wasting space on your OS. Let's take a look at our undo table spaces. What I'd like to do is show you how to add an undo table space and then switch what the active one is. You can select from the DBA table spaces view and you just grab the table space name, the contents, and the status, and these are all online. So undo TBS1 is our undo table space. You can also type in show parameter undo, and you'll see where undo table space is listed there. Now, it's okay if there's nothing there, if that value is blank. If there's only one undo table space, it's going to default to that one table space. But if you have more than one undo table space defined in your database, you have to have that set to a value. You can also see which data files correspond to your table space. So here we're grabbing from our DBA data files, just grabbing the file name where table space name equals, and then the value here. Make sure that's in all uppercase letters, because remember, all of your data dictionary objects, everything is going to be stored as uppercase letters. Now let's create a second undo table space. It's not going to be active, but it will exist on the system, and we'll call it undo TBS2. Really, you can call it anything you want as long as it's under 30 characters. And then we specify the data file name. Now on Windows, it's not case sensitive, but on Unix and Linux, it is. Okay, so you have the full path of where you want the corresponding data files. Now the naming convention for the file is the name of the table space followed by an underscore and then 01. If there's a second file, 02, and so on, .dbf. Okay, so I'm making this 2 megabytes initially. This reuse clause, once again, just means that if the file already exists on the OS level, it's going to clobber that file instead of giving us an error. Auto extend On means that it's going to automatically grow if needed. Okay, so that will go ahead and execute, and we've got a table space. And we go ahead and issue this query again. Now you see we've got two undo table spaces. But when we say show parameter undo, it still tells us undo TBS1. So let's go ahead and alter our system to make it point to this new undo table space. Okay, we issue that statement. Then let's go ahead and issue this select statement one more time. And now when we say show parameter undo, you'll see that it's now changed to that. Now, how about dropping the original undo table space? Pretty easy. Drop table space, the table space name, including contents and data files. Now our table space has been dropped. And I issue my query again just to see what we've got, and that's the only undo table space now. So pretty easy, isn't it? Let's assume that your database is using the old-fashioned rollback segments and you want to convert that to use automatic undo. Well, before you perform the conversion, you need to know how large to size it. So Oracle provides us with a package called DBMS Undo Advisor, and there's a function in there called RBU migration. And all it does is it returns a number that tells us in megabytes how large our undo table space should be. So what I've done here is I've assigned that to a bind variable called n, and I declared it right here. Then I can just run my anonymous block and then print out my n. So I'm on a really small database and there's not much activity. I only have 10 megabytes that I need to create for my undo table space. So then you would just create the undo table space like I showed you earlier, and then you would modify your undo management to say auto instead of manual. And if that was the only undo table space in your database, then of course you do not have to set the undo table space parameter. It's also helpful if you set the undo retention. If you leave undo retention blank, it actually defaults to 900. If you want to tap into the data dictionary and find out if there's any active undo in your table space, then run this query. You're going to run it from DBA undo extents and just grab the owner, table space name, bytes, and the status, where status equals active. Now right now we're not going to get any results, but if you see that I open a new window, you see that I'm logged in as Scott and I've got this emp table that looks like this. Let's go ahead and give everyone a 10% raise. Okay, so we gave everyone a 10% raise. That update statement started a transaction. Okay, so let's look at our other window and run this query again, and you'll see that we now have some active undo. As soon as I perform a commit, that ends the transaction, and that undo information is no longer active. It's now expired. So let's run our query again and see that there are no rows returned. I'm now changing my query to say where status equals expired, and you'll see that it now shows up there. Keep in mind that if you have any active undo in a table space that you're trying to drop, Oracle won't let you drop it. It has to become expired. Wrapping up this nugget, we already talked about why we'd want to use undo and looked at the difference between undo versus rollback segments, as well as configuring your undo table space and sizing it appropriately. And hopefully if you utilize your Enterprise Manager, you take advantage of this undo advisor as well. You should feel pretty comfortable creating your undo table spaces, as well as altering, dropping, and switching them out. I hope this has been informative for you, and I'd like to thank you for viewing.